Okay, two reduction reactions. So reduction is gain of hydrogen or loss of oxygen, or reduction is gain of electrons, but we're just going to be looking at those two today. Okay, carboxylic acid to aldehyde to primary alcohol. You're probably familiar with the reverse reaction going that way, and that was oxidation, with reflux and distillation, all of that malarkey. So in this video, we're going this way. H in square brackets means reduction. So carboxylic acid, a generic formula looks like this. Carboxylic acids are responsible for the smell of your smelly feet. That's propanoic and butanoic acid. The aldehyde, well, that's responsible for a hangover after a hard night of drinking. And a primary alcohol, well, you can only drink one alcohol and survive, really, and that would be the primary alcohol ethanol. So what is doing all this reduction? Something to do with hydrogen, eh? Well, it's actually the hydride ion, H-. So that's just like a regular hydrogen atom, but with an extra electron. So this is behaving like a nucleophile. Which means it's attracted to positive things. Now, what is positive on this molecule and on that molecule? Because that's where the hydride's going to attack. Well, there's a dipole, a bond dipole here, and bond dipole there. Oxygen has a much higher electronegativity than carbon, so oxygen's going to drag the electrons in the bond towards itself, making oxygen a little negative, leaving carbon a little positive. That would make the carboxylic acid and the aldehyde electrophiles. They're attracted to negative. So the hydride ion itself is the reducing agent. So reducing agents are themselves oxidized. And since reducing agents are themselves oxidized, oxidation is loss of electrons. The hydride ion is going to kind of lose its electrons. It's going to donate it to the bond between itself and carbon. So what kind of question could we ask? Well, we could ask about the kind of partial, that's halfway, or full reduction of, let's say, ethanoic acid, which is vinegar. That's the one they like to do. So how would I turn this into ethanoic acid? Well, I know ethanoic acid has 2 carbons, so I just knock off the R. The R could be methyl, ethyl, propyl, butyl, etc., or even hydrogen. And replace that R with CH3. And the second reaction you need to know is ketone to secondary alcohol. Well, let me just fill in the hydrogens. If you miss one hydrogen anywhere at any point in your exam, you lose 1 point, but a maximum of 1 point. Again, let's put H in square brackets to denote reduction. And let's have a look. Where will the nucleophile go? There's H-. It's going to be attracted to the most positive part of the molecule. So it's going to go to there. And again, this is positive because the oxygen is highly electronegative compared to carbon. It's drawing the electrons up here. There's a little bond dipole just there, making the carbon positive. So if this is the nucleophile, then this must be the electrophile. You don't need to know details of the mechanism. And what about this monster here? What could happen if I reacted that with a hydride ion? Well, first of all, where would the hydride ion go? There's my H- ion. It's going to go here because the carbon's a little bit positive. Another one's going to go there and another one is going to go there. So what would be the result of this reaction? Well, for the aldehyde at this end, that's going to reduce to a primary alcohol. For the ketone, that's going to make a secondary alcohol. And for the carboxylic acid, if we go all the way back, we're going to end up with a primary alcohol. And there we go. What's the name of that? I think I can do that. 1, 2, 3, 4, 5 carbons, so that's going to be pentan. I can see there's alcohol groups, the OH group, so it's something ol. And I've got an alcohol group on the first one, third one, and the fifth one. So I'm going to have 1, 3, 5, and it's triol. So pentan 1, 3, 5 triol. I bet that has a very high boiling point because it has lots of hydrogen bonding. The IB is going to trick you and go, oh, is that a hydrogen bond? No, that's a covalent bond. Hydrogen bond is intermolecular between one molecule and the next molecule. And we are done.